Hello guys, welcome back to the course. In this video, we are going to start the third project. We are going to map flood risk. Let's read the problem. Flooding poses significant risk to communities and infrastructure. Therefore, we need to have accurate flood risk mapping to help in disaster preparedness planning and mitigation efforts. So in the third project, we are going to analyze flood risk in Manila. That's the capital city of the Philippines. In addition to that, we are also going to map which locations that have high risk of flooding and which locations that have lower risk of flooding. Okay, let's get started. Let's go to Google Colab. The first thing that you need to do is to install Volume. So let's copy this and let's compile the code. As you guys can see, we have successfully installed Volume. Next, we are going to import several Python libraries. Firstly, we are going to import pandas. Next, we are going to import Volume. We are also going to import heatmap from Volume. And lastly, we are going to import Google Colab files. We are going to use this library for uploading dataset. Okay, let's compile the code. Next, we are going to upload the dataset. Just a quick reminder, guys. We are going to use this dataset, Metro Manila flood landscape data. So make sure that you download this dataset. Okay, so let's create a new variable. I'm going to name it uploaded. You can name it whatever you want, and we are going to upload the data using files.upload functions. And let's compile the code. Let's click choose file. So this is the dataset that we are going to use. Let's click open. Okay, so now it is uploading the data. It might take a few seconds. Hopefully it doesn't take too long. Okay, we have successfully uploaded this data. Next, we are going to load this dataset. Let's create a new variable. I'm going to name it data. You can name it whatever you want, guys. It is totally up to you. And we are going to load the data using pd.readcsv functions. And let's copy and paste this file name and put it inside the parentheses. And let's compile the code. Next, I'm going to display the first few rows of the dataset, data.head, and let's compile the code. Okay, this dataset has 5 columns. The first column is the latitude, the second column is the longitude, the third column is the flood height, the fourth column is the elevations, and the fifth column is the precipitations. So there is a good news, guys. We don't need to do geocodings because we already have the geographic coordinate for its locations. And to analyze the flood risk, we are going to take these 3 factors into considerations. Okay, so now let's talk about the relationship between these 3 columns with flood risk. Let's get started with flood height. So this is the flood height based on historical data. It is directly proportional to flood risk because areas that have experienced higher water levels in the past are more likely to flood again, indicating a greater vulnerability and risk in those locations. So the higher the flood height in the past, the higher the flood risk in the future. Okay, so now let's talk about elevations. So elevations is inversely proportional to flood risk because higher elevations are less likely to be submerged in flood waters, making them less vulnerable to flooding compared to lower lying areas. So the higher the elevations, the lower the flood risk. Okay, so now let's talk about precipitations. So precipitations is directly proportional to flood risk because increased rainfall leads to more runoff and higher water levels, increasing the likelihood and severity of flooding in the affected areas. So the higher the rain precipitations, obviously the higher the flood risk. Okay, so let's go back to Google Colab. Now we are going to clean the data. We are going to convert columns to numeric types, and we are going to remove all missing values in these data sets. So let's create a new variable. I'm going to name it numeric columns. You can name it whatever you want. It is totally up to you guys. Okay, so inside this bracket, we are going to have like 5 columns names. The first one is latitude. So you can copy and paste this and put it inside the bracket. The second column is longitude. Let's copy and paste this and put it inside the bracket. The third column is flood height. The fourth column is elevations. And the fifth column is precipitations. Next, we are going to convert the cursing errors to NaN, or not a number. Let's copy and paste the numeric columns and put it inside the bracket. In this case, we are going to use .apply functions. pd.toNumeric. And we are going to set the errors to coarse. Next, we are going to drop rows with missing values. I'm going to create a new variable. I'm going to name it data cleaned. You can name it whatever you want. And we are going to utilize drop NA functions. Next, we are going to check if the dataset doesn't have any missing values. I'm going to print NaN after cleaning. Data cleaned dot is null dot sum. Okay, now let's compile the code. Okay, so all missing values have been removed. So the data is clean and ready to use. Next, we are going to calculate the risk of flooding in its locations in Manila. But before that, we are going to normalize the data. In this case, we are going to use this formula. So we are going to subtract x by xmin and divide it by xmax subtracted by xmin. So let me explain, guys. Let's pick this as an example. So the elevations is 54.5. We are going to subtract that by the minimum elevations, and we are going to divide that by the max elevation subtracted by min elevations. Okay, so let's get started. From now going forward, we are going to use data cleaned. And I'm going to create a new column. I'm going to name it normalize flood height. Okay, so let's apply this formula. Okay, so let's copy and paste this and put it inside this bracket. firstly, we are going to subtract x by the minimum value, right? So we are going to use .min functions. This is supposed to be inside the parentheses. And next we are going to subtract the xmax with xmin. Dot max subtracted by data cleaned dot mint. Okay guys, so we have normalized the float height column. Next we are going to do the same exact thing to the elevations and also precipitations. So you can copy and paste this line guys, because the logic is going to be the same. We are just going to change the column's name. Okay, so now we are going to replace the normalized float height with normalized elevations. We are also going to replace every float height in this line with elevations. And for the third line, we are going to replace the normalized float height with precipitations. So you can copy and paste this. Okay guys, we have normalized the data for these three columns: float height, elevations, and precipitations. Okay, so let's compile the code. Next, we are going to invert the normalized elevation. You might be wondering why. Well, in this case, elevations is inversely proportional to the float rates. So the higher the elevations, the lower the float rates. That's the reason why we need to inverse the elevations. Okay, so let's copy and paste the normalized elevations and put it inside the bracket. We are going to subtract 1 by the normalized elevations. And let's compile the code. Let's add another block of code. Next, we are going to calculate the race score. So let's create a new column. I'm going to name the column race score. You can name it whatever you want. It is totally up to you guys. Next, we are going to multiply the risk factor like float height, elevations, and precipitations with the weight. And this is going to be very subjective because we are going to assign the weight to each risk factor. In this case, I'm going to make an assumption that float height contributing 40% to the float risk, elevations contributing 30% to the float risk, meanwhile precipitations contributing 30% to the float risk. Okay, so let's do the calculations. Data cleaned. Let's copy and paste the normalized float height and put it inside the bracket. Then we are going to multiply this by 0.4. We are going to add this by the normalized elevations. Let's copy and paste this and put it inside the bracket, and we are going to multiply this by 0.3. We are going to add this by the normalized precipitations. Let's copy and paste this and put it inside the bracket, and we are going to multiply this by 0.3. If you want to assign like different weight, it is totally up to you guys. Once again, this is very subjective because the calculations is based on my assumptions. Okay, so now let's compile the code. Next, we are going to print the risk score for its locations. Okay, let's create for loop to print the risk score for index and row int data client dot iterows. Inside this for loop, we are going to print all the data. Firstly, we are going to print the latitude, let's copy and paste this column name and put it inside the bracket. Next, we are going to print the longitude. Let's copy and paste the column name and put it inside the bracket. Next, we are also going to print the float height. Let's copy and paste the column name and put it inside the bracket. And lastly, we are going to print the risk score. Let's copy and paste this and put it inside the bracket. Just a quick reminder guys, we already have the double quotation here, so make sure that the quotation inside this bracket is a single quotations, not double quotations. Okay, so now we are going to compile the code. Okay, so here is the output. Let's read the output. Let's pick one example. So this is the first locations. We have the geographic coordinate like latitude and longitude. The float height in these locations is 0 and the risk score is 0.25. What about the second location? So this is the latitude, longitude, the float height is also 0 and the risk score is 0.37. So the second locations has higher risk of flooding compared to the first locations. Okay guys, I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.